Okay, so today we're going to continue with cubic function. So cubic function generally is ax cubed, bx squared, cx plus d, where the coefficient of x cubed cannot be 0. Let's say if the coefficient of x cubed becomes 0, it will become quadratic. So that's why we must have the existence of the x cubed term, the term of x cubed. Alright, so the shape of cubic function, it will be in the S shape, whether you're going to the smooth S shape, going up or going down, or you might get another shape, it will be more curving, okay, more curving, we're going up and then curve down, then only curving up. Then this one is curve down and then curve up, then curving down. So whether it's a smooth S shape or the more curving like this, it will depends on your functions here. So for the function only have x cubed term plus a constant, it will be in the smooth S shape. So plus d, it will depends on if your d here is positive, means it will intersect at positive y-axis here. If your value of d is negative, you're going to intersect at negative part. So if you're having your cubic with all the bx squared cx term exist, then your cubic function will be in more curving like this. Alright, the shape will be more curved. So it's not like a smooth curve. So the domain and range, so domain and range, we refresh back here. For cubic, domain and range, both of them are not our special case. So that's why our domain always infinity to infinity, negative infinity to infinity, range also negative infinity to infinity. Alright, so for the S-shaped curve here, whether it's going up or going down, it will depend to the coefficient of x cubed. If your coefficient of x cubed is positive, okay, means your value a here is positive, your shape of the graph will be going up. If your coefficient of x cubed here is negative, then your S shape will be curved down. Alright, so this is basically, or we can use our calculator to find out our roots. So you can use your calculator, key in your equation, find your mode of equation. Then we choose for the cubic function to find out what is your roots. If you get your roots is one root, means your curve will be like this, whether it's going up or going down. If you're getting your roots is 3 roots for your function, means your curve will be like this. Here will be your existing of your 3 roots. This will be your existing of your 3 roots. Alright, so we look at example, sketch the graph. Sketch the graph. So first we practice the domain and range first, although this question doesn't mention. The domain of the function for cubic will be infinity to infinity. For range also negative infinity to infinity. Cubic function is not special case. Alright. So in order to draw our first graph here, x cubed with the existence of x squared and the term of x, means this graph it might be in the curving x. The curving x is not the smooth x. Alright, so if smooth x, it only have x cubed and the d. So if you have those bx squared and cx, most probably we will have the curving x like this. So whether going up or going down, depends on your coefficient of your x cubed. So if your coefficient of x cubed is positive, means it's going up. This is question A. So you see your coefficient of your SQ is negative, means this is our question B. It will be curve S shape going down from the left hand side to the right hand side. Alright? Okay, so we can use our calculator to find out what is our roots. What is our root? So you can find in your calculator in the mood equation, you take cubic. The general form here you have cubic. Then you key in your A is, coefficient A is 1, B is negative 2, C is negative 5, D is 6. Then you'll notice that you'll get your first root is 2. Second root is value 3. Then third root, value of 1. So your first root is negative 2. So confirm, like this we confirm our x curve will be the curving x, having the 3 roots. It's not the smooth x. If your graph is in the smooth x, it only will be having 1 root on the x-axis here. Alright? Okay, so then we start plot out, label out our x-axis and y-axis with our roots together. Label our x-axis and then label our y-axis. Okay, then plot down important point where we have x-intercept here negative 2, the roots here having 1 and 3. You have 3 roots. So your graph, it should be going, your graph, your x here is positive. So your shape of the S curve here should be going up. So from the left, we go up and then we U-turn first, make a curve, then going up again. Alright. Then we see the intersection when x is 0, when n is 0. Our y-intercept here is 6. So you must intersect your y-axis as positive part. Don't overcurve it, go down, then intersect at here, they will be wrong already. Okay, so intersection at value of 6, so at positive part here. Okay, so we start drawing our graph, our S-shape curving. So going up because A is positive, so it will going up. So from the left here, we're going up first, then we make a curve, continue to go up. So it is okay when you didn't have your point plotted here, we just relabel. We label it nicely like this. As long as it is accurate at the place where positive will be at the positive, you have 2 roots at the right hand side, 1 root at the left hand side. And then intercept should be the value of 6 at positive part of the y-axis. So here will be our cubic graph. So lastly, double check whether you have your labeling or not, x-axis, y-axis, and your function. Write down your function. So I label here fx equals to x cubed minus 2x squared minus 5x plus 6. Then we go for question B. Okay, we revise. For cubic function, domain for this function g, it will be negative infinity to infinity. Range for function g also will be negative infinity to infinity. So from here we can enhance and see, correct or not, why we say domain negative infinity to infinity? Because for our cubic graph, we will start drawing from left hand side up to right hand side. Nothing to limit us that we cannot draw the graph. And then we can draw from the bottom range. Range we're going to see or y. From the bottom we can draw up to above here, up here. Nothing to limit here. So any value can be axis. So that's why our domain will be negative infinity and to positive infinity. Range also like that. Alright, so go back to the graph here where our function is negative, means our graph will be having the S shape going down. Alright, so whether it's a smooth or the curving X, then depends on our roots. If you're having one roots, then we'll draw the smooth S shape. If you have 3 roots, then we'll draw this. So you can check with your calculator how many roots that you have here, where your A is -1, B is 2, C is 5, D is -6. So you're having the first root where x is equals to -2. And then second root, x is equals to 3. And then you have third root where x is equals to 1. So shape we already know, which is the curving x. It's not the smooth x. Smooth x only we're having one root. Then we can draw our graph, okay, setting up our x-axis and y-axis, and we know that this graph will be intersect at x-axis where its root occur at -2, and then value of 1 and value of 3. And this graph will be going down to the right because the coefficient of x cubed is negative. Okay, so where you're going to intersect, they will intersect y-axis and -6. So they will intersect here at the bottom here. So don't intersect at here. So you try going down, okay? So you're going down, pass through the first root. Alright, going down. Pass through the first root, then curving up, and then continue. So this will be your S shape. So your intersect will be -6. Lastly, label our function. So for cubic, we were looking on its properties where's the roots, where's the y-intercept. Then lastly, make sure your graphing must be in label with y-axis, x-axis, x-axis, y-axis, and the graph and the function. So this is gx. This is not fx, this is gx. Writing error.